power. Anyone have an idea what power you should raise that to? 2/3. If I raise this to the 2/3 and I raise this to the 2/3, what happens? Multiply the two powers. What's 3/2 times 2/3? 1. 6/6, right? So that gives you a 1. And that whole thing to the 1 power is just that whole thing. I realize that this is somewhat ugly the first time you're seeing it. Keep going here. I'm just going to erase all this. Okay. So the left side is now 27 over pi to the 2/3 equals the right side, which is just 1 over 4 pi times a. I can multiply by 4 pi on both sides, right? That would work. Multiply by 4 pi. I want to go further. I know you don't want to, but I want to go further because when I see 2/3, I realize that that is a cube root. Yes?
The original volume was 36 pi, but you only put...
Was it pi?
Yeah. Yeah, it was 36.
Ah, I'm so glad you caught that.
Why not change? That makes it a lot easier.
Well, it's going to make it a lot easier. Okay, I wrote it down. Look, it was 36 pi. I have it written down 36 pi everywhere else except where I wrote this down. I didn't write the pi here. Look, it's going to be a quick fix. This pi, right there. And then when I divide both sides, I can get that pi out of here, can't I?
Yep.
Okay. That's going to be so much easier now.
So does the 27 not have a pi underneath it?
It does not have a pi underneath it. I'm so glad you caught that. Did anyone else catch that? Say something, man. I'm so excited up here. All right, so this, does everyone see what happened? I forgot to write the pi down, and when you divide pi on both sides, it goes away. Multiply both sides by 3/4, and you get 27. So we no longer have this divided by pi. This is still the same, right? Over here, though, this is just 27, right? And then this right here is just 27.
So you have 12 pi.
Yep. So just make sure you understand that 27 to the 2/3 is the same as the cube root of 27 squared, which is 3 squared, which is 9.
So wait, area is 36 pi.
Is, well, I don't know, what is it? 4 pi times 9 equals A. So the area is 36 pi, but the units are different. It's an area, not a volume. Square feet, not cube feet. It just so happened. It didn't, it's not always that way. All right, so area is 36 pi square feet.
I thought it was 3. Wasn't that?
3?
Oh, never mind.
But the squared, right?
So that's the same.
Okay. All of that was just to get A, right? It was just to get A. So now I'm ready to plug that in and get a final answer.
So what is the shortcut?
The shortcut is that we can answer the question. That's the shortcut. All right, so here we go. Back to this. dv dt equals, let me clean this up. This was, the 3's were gone, right? This 2 goes into here twice. So that's just what? 2 pi out front. And then I have in here 1 over 4 pi times the area, but the area was what? 36 pi. Oh, that's great. What was dA dt? 20. Oh man, this is just going to clean up so nice, isn't it? These pi's cancel. 36 over 4 is 9. The square root of 9 is 3. So that all is going to be 3. And this pi and this pi cancel. 20 divided by 4 is 5, and times 2, and then this was 3, right? I lost my place. 30. I think it's 30. Okay. 30. 30 what? Cubic feet, because it's volume. Cubic feet per time second. Whew. Yes?
Just find it and just put it up like 8 hours square. It will be easy.
If you did what?
Define R, put in the formula, and then put in the 8 hours square. It will be easy to find A.
You could find, yes, to find A. Yeah. Yeah. Let me, I know that y'all would agree with me that that was a little more difficult than the one before, right? Okay. I want to back up just to show you that there are some different ways to get there, all right? Let's go back to the part that caused us the issue. We had volume was equal to 4/3 pi r cubed, and we had area was 4 pi r squared, right? Let's just say I differentiated right now. Let's just say I did with respect to time. I get dv dt, right, equals 4 pi r squared dr dt. That's what I would get if I differentiate this with respect to time. Yes, but I brought the 3 out. So I think I did that, like I left the 4/3. I brought the 3 out, and the 3 canceled with the, I went too fast. I'll go. That's okay? You sure? I'll write it.
Okay.
There we go. I went a little too quick. 4 pi r squared dr dt. That's what I would get had I differentiated. And we said that was bad because this has r in it and dr dt. We don't know anything about dr dt, right? Agreed? Here, if I differentiate, I get dA dt equals, what would I get here? 8 pi r dr dt. Understand? Now, even though those don't look like they would work, if you could tell me what r is, right, then I might be able to figure out what the answer to this question is. Do you know what r is from the picture? Go back to the picture at the moment in time. We said the volume was 36 pi, right? Volume is 4/3 pi r cubed is 36 pi. Could you solve that for r? Yeah, so let's do it real quick. Flip up, what is it? 3? So r would be 3. I'm going very quickly through this. I'm just showing you that there's another way, okay? That's all I'm doing. All right. What are we trying to find in the problem? D what, D what? D what? dV dt, is that what we're trying to, but we know what dA dt is. dA dt is what? 20? If I plug 20 in here, 8 pi, and I know what r is what? 3, then couldn't I solve for dr dt? Yeah. Look at that. And then what I could do is come back over to this one, plug in r's 3 here, and dr dt is whatever I got as that answer there.
Why didn't you do that one?
I'm showing you 2 different ways. Look, there's more than one way to skin a cat, I guess they say, right?
I like this way better.
You have the freedom to approach it however you would like. You hated the other way because you had to solve that equation? That's an important thing to demonstrate, is that you can use 2 equations to come up with a new equation. All right, classic plane flying overhead problem. You don't like this one? It's a good problem, man.
I tried to do it when you were doing it. I was like, I can't do this.
Yeah. All right, so this is now getting into something a little more applicable to real world because you have a plane that's flying overhead at a certain speed. The plane is the red dot, the person on the ground here. And as it flies overhead, we're trying to measure how fast the distance between the plane and the person is increasing or decreasing. Another way to think about this is, let's say that there was a rope connected between the person and the plane. They're very dangerous, right? And so you've got this spool of rope that you're holding down here, and the plane's flying overhead. Then that spool's going to be letting out rope, right? And what you want to know is, how fast is the rope coming out of the spool? Like, what's the speed of the rope coming out at a certain point in time? Another way of saying that is, how fast is the distance between those two increasing or decreasing? So let's just put the word problem up here without the picture. The problems that you're seeing here are classic Cal 1 related rate problems. You know, the plane flying overhead problem. Everyone who's done Cal 1 knows this problem. A plane is flying horizontally at an altitude of 2 miles and a speed of 600 miles per hour. The plane is headed directly over a ground-based radar station. At the moment the plane is 6 miles from the radar station, how fast is the distance between them changing? I don't know, who cares? So we have to start with a picture. The general picture is a plane. Now this is where you can impress me with your artistic abilities. You can draw a plane.
Do you want to see the people in the plane?
This, like I said, you could impress me with your artistic abilities. That's obviously an F-16.
Is it?
What's a missile?
And that's my plane, and it is flying horizontally. My radar station is right here. I know, don't be jealous. I've been doing this for years. So, I mean, if you see these pictures and you're just like, wow, how is his plane so good? How is his radar station so yes?
Does it matter where it means by 6 miles from the radio station? Does it mean like...
I'm so glad you asked. I'm so glad you asked that question. The question is, 6 miles from the radar station, you could actually look at that two ways. You could look at, if the plane's going this way, there is a point where it's 6 miles, right, from here to here. But then once it goes past, there's another point where it's 6 miles. It's up to you, because the problem doesn't state that, right? It doesn't state it. The thing is, when you're right here, the distance between you is closing, right? Here, the distance between you is increasing, right? The rate will be the same on both sides. Just one of the answers is going to be negative, and the other one's going to be positive. Negative means it's shrinking, yes, and then positive means it's growing. Understand? So the plane's flying overhead, and yeah, that's my picture. That's my picture, my general picture. Now at the instant in time, I have the plane here. I'm going to draw a dot now, okay, so I'm going to go back a little more primitive. And then I have the radar station. And what we're interested in is the point at which the distance between them is what? 6 miles. So I can actually label this right here 6 miles. Hey, there was something else in my picture over there in general I forgot to put in here that stays the same the whole time. The altitude of the plane. The altitude of the plane was 2 miles, and that is not going to change. 2 miles, 2 mi. Yes? The speed is also, but the speed, I have to be careful. I can't label like a side or anything the speed because it's always changing. What I could do is just up here, right, 600 miles per hour, like in that direction, to let everyone know like the plane is moving that direction is 600 miles per hour. It's kind of like when you were asking about the dr dt on the circle. You can't put it on the circle because that point's moving. Okay, are we all right so far? Now this 6 miles, the distance between the plane and the radar station, I haven't labeled it on this picture, so I should probably draw that line here, shouldn't I? And over here in this picture, I should probably give it a variable because it is moving, it is changing. So what do you want to call that? Do what? Well, no, it's the length. It's the distance from here to here. See, it's not a derivative.
H.
Call it h. That's fine with me. H.
Do you want to give the
No?
No, if you're using the formula 1/2 space times height, that h is equal to.
Yeah.
If you are using it, yes.
You use the.
I'm not quite sure you'll be using it, but that you might want to avoid that because you might confuse it with height, right? Okay, so what would you call it? Z? Okay, I like Z. I actually, when I draw triangles, I use X for this side, Y for this side, and Z for the hypotenuse. For the exact reason that I might use H for something like height later. But it won't hurt us in this problem to call it H. That okay? All right, let's write down what we're given because I might be able to continue to draw if I have some given information. And what I want. Maybe you can help me. And maybe the equation. What's easier for you to tell me right now? What you're given or what you want? Okay, go ahead.
600 miles per hour.
600 miles per hour is what? D, it's a derivative, right? Because it's a speed?
Yeah.
But it's a derivative of what? It's d what? You said dx dt, but where's x on the picture then?
So the horizontal.
Okay, so you're going to have to draw a right triangle here. And you're going to have to say that basically the distance between these 2 points, we're going to call that x. Do you all agree with that? I could do that. Then if this point does not move, right? This point moves. And how fast is it moving? How fast is that moving over? This point's moving over that direction at 600 miles per hour.
So very fast.
So is x getting bigger or smaller?
Smaller.
Smaller. Do you agree? In this picture, x is getting smaller. Now if we put the plane on the other side, x would be getting bigger. So when I write what I'm giving, I don't know if you caught that. X is going to shrink, but if the plane was here, x would be growing. Okay, so when I write given, I'm going to say dx dt is 600 miles per hour, but what here? Positive or negative?
Positive.
Is x growing or shrinking in your picture?
Well, if it's over here and it's going this way, it's going in a positive direction.
That's not this distance, relative to the ground station, does this length get bigger or smaller? If x is getting smaller, then that means the rate at which x is changing is negative. That's what I was saying. If you drew the picture with the radar station here and the plane over here, okay? Sorry, my plane's not as fancy when I'm drawing fast. Then here would be your triangle, this would be your x, and now this point's fixed, this point's, now x is growing. It just depends on how you draw the problem when you set it up. In the homework problem that's like this, the plane's on the other side.
So it'd be negative 600.
Negative 600 miles per hour is dx dt. That's what we're given.
Would it just be easier to put it on the other side?
It's up to you.
Doesn't matter.
Doesn't matter. I'm doing it this way because in the homework there's a problem like this, and I did the video of it, and the plane is on the other side. So now you've seen them both. You will have seen them both. All right, what do we want? What do we want? The rate at which the distance between them is changing, which is the h variable, isn't it? We want dh dt. How fast is that h changing with respect to time? When do we want that?
6 miles.
At what 6 miles? At h is 6 miles. Why is it not x is 6 miles? Because that's the biggest mistake students make with this.
That's not the distance.
The distance between them is the distance between them, not the distance between the radar station and its like projection straight down, right? That's x, this is h. I want to know how fast that's changing. With me? Okay, that's it. We should have enough here. If you can come up with an equation that relates these two together, h and x, off your general picture. Pythagorean identity? Remember, for any right triangle, a, b, and c, a squared plus b squared is c squared. So if I rewrite that, this identity, using this, I'll have what? X squared plus 2 squared, which is 4, must equal h squared. A squared plus b squared is c squared. Yeah? 2 squared. Right, remember this side doesn't change. That's key. If he's changing altitude, that's a whole different problem. If I differentiate this equation with respect to time, I will find it myself with a dx dt, which is good, and I'll find a dh dt, which is what I want. So I should be able to use this. Derivative time? Okay, let's do it. The derivative of this with respect to time is 2x dx dt plus the derivative of 4, 0, equals derivative of h squared, 2h dh dt. Yeah. So when we look at this thing, we say, all right, do I have x? At the moment in time, do I have x? No, I don't, do I? At the moment in time, what I do have, I erased the picture, was this was 2, and this was 6, right? And this was x. I hadn't figured out what x is. So I'm going to need to find that, right? So that I can do. I'm going to come back to that. How about everything else? Do I have everything else? dx dt, negative 600, right? H, do I know h at the moment in time? 6, right? And then dh dt is what I'm trying to solve for, isn't it? So I should be in business as long as I can find that x. So what am I going to use to find the x? Pythagorean, right? Right here. So do your quick little Pythagorean on that. You'll get x squared plus 4 equals 36. So x squared is 32. X is root 32. Only taking the positive one because x is the length right here, so it can't not going to be negative. Questions? Now let's write this down. I'm going to cancel these 2's, divide both sides by 2, just because there's no need for it, right? X we said was root 32. dx dt was negative 600. This must equal h, which was 6, times dh dt, which is what I'm solving for. And what would you get if you divide both sides by 6?
Square root of 2 over 36 times 100.
Yep.
Negative 100.
So negative 100 root 32 is dh dt. What are my units here?
Miles per hour.
Miles per hour. I'm also right now, just because this is a plane flying overhead and we want to know how fast that distance is changing, I'm going to go ahead and get that number as a decimal. I get negative 500 Whoa, is that what I got?
Yeah, sure.
Okay. I was freaking out there for a second. I'll tell you why after I write this down. Approximately. Miles per hour.
Do you have to specify from what direction it's coming from?
Do I have to? Do you have to? No. No, in the problem it doesn't, right? It just says how fast is the distance between them changing. You could just say 565.7 miles per hour. So if you're holding that rope, right, and the plane was traveling away from you at 6 miles, at exactly 6 miles away from you, the rope's coming out of your hand at 565 miles per hour. Just ripping through your flesh, right? The reason I freaked out initially is because I thought that the speed of the airplane was 500 miles per hour. And I was like, it couldn't be
Faster.
coming towards me any faster than it's flying, right? Unless I was moving. So, but it's 600, so that's okay.
I don't think you could run 47 miles an hour.
Yeah. All right, what do y'all think?
Is that it?
Mm-hmm. Yep. Same setup, different problem. Same plane flying overhead. Same speed, everything. The difference is that I'm not interested at all in the distance between me and the plane and how fast that distance is changing. I want to make sure that if this plane is traveling at 600 miles per hour, that I can keep track of how fast my angle of elevation is changing if I'm tracking it visually. So this is this goes back to like if there's a plane flying overhead and you're following it, right? You know, you're trying to follow this plane going overhead. This angle, right? If it's really far away as it comes towards you, you don't have to turn. Well, let me do it this way. You don't have to turn your head very fast until it gets closer, and then that speeds up, and then as it goes by, that's slower, isn't it? It's almost like, the other analogy I have is if you've ever stood like at a racetrack or something, it's like you're watching the car come. You know, this in this range, right, it's fast, and as it goes away, it's slower, right? At any point in time, we should be able to measure how fast you're turning, your change in angle. Does that make sense? All right, well, let's do it. 600 miles an hour, 2 miles high. At the moment it's 6 miles from you, how fast is the radar rotating as it's tracking it? Understand the question? So the good news is all my pictures and everything are going to look the same as far as the plane. I still have a plane. I still have a radar station. Right? But this time, instead of being interested in the line connecting them, I'm interested in not that, but this angle right there is what I'm interested in, right? And this right here is still 2. That's still fixed. And I'm going to actually label this angle. What should I use? X, Y? Theta. Yeah, let's do theta. And over here in the instant in question, at the instant in time, what can you tell me about the instant in time? 6 miles between, right? This is 6. And of course, this is still what? 2. Right? Pardon? We would know x, right? It would still be root 32. But That's the instant time. This is the general picture. Let's write down what I'm given and what I want. Which of those do you think you could fill in right now easily?
We can figure out the given.
What is given to you?
It's the negative 600.
Okay, and what is that? It's the speed?
over
dx dt. That means I need to label x here again, right? Does everyone agree? I'm going to have to label this right here x again because dx dt is given to me. All right, what about what you want? How fast is the distance? Wait a minute, hold on. Oops. I apologize. I brought the. How fast? I had the other problem up there.
We want,
How fast is the what?
we want d theta over dt.
Good. We want d theta dt. How fast is the angle of the tracking radar changing? We want d theta dt. That's a variable, right?
At 6.
At exactly what?
36 miles.
At what 6 miles? Ooh. Ooh, h, but we haven't labeled it, have we?
We can call it.
We haven't labeled it, have we?
We can call it z.
So why don't we do this? Since we just did the problem before it, we're using the variable x, aren't we?
Yeah.
I could put h in here and then say h is 6, right? But now I'd have more variables. I could just solve for this side right now, which we've done already.
Yeah.
This was root 32, wasn't it? So I could say at what?
At root
At what's root 32?
x.
At x is root 32. Saying h is 6 is saying the same thing as x is root 32. Was that a question?
Yeah.
Uh-huh.
Well, I had a question. This could apply to the other one. How come when we're taking the distance of 6 miles applied to the hypotenuse versus the base?
Well, if I said what's the distance from me to you right now, would you measure the distance from me to that perpendicular that goes from here, like, and then turns to you? Like, would that be the distance we're talking about?
Horizontal distance or slope distance? That's what I'm trying to, like, how do you differentiate that?
Well, and that's why I said a second ago, students will confuse the two and they'll think they're talking about x is 6 instead of the h. And it's because it's implied that when we say the distance from point A to point B, we're talking about the straight line distance between them. That's what's implied. It's never implied that the distance between, look, it's distance between point A and point B is never the distance from here to here. For some reason, people do that. I mean, it's very natural that you would measure the distance down here straight across. I don't know if that answers the question. If they said, like, what is the horizontal distance? Then yes, I would agree it would be distance from here to here. Any other questions or issues? Got about 7 minutes.
This is a 2-day section, right?
Yeah, we're going to spend 2 days on this. Yep. All right, we have theta and x. And we're going to look at our general picture. We're going to try and come up with a way to relate theta and x together. Close, 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 close. Tangent. The tangent function from pre-cal. Tangent is which side of a right triangle over which side? Opposite over hypotenuse. Does everyone agree? Tangent of theta is 2 over x.
Opposite over adjacent.
Opposite over adjacent. Is that what I said?
You said opposite over hypotenuse.
Oh, I did? I'm sorry. Opposite over adjacent is what I meant to say. I could also use cotangent, because cotangent is adjacent over hypotenuse. It's up to me. I don't care. It's up to you. Anything. It doesn't matter. As long as the two are related. Y'all want to stick with tangent? Yeah, let's stick with tangent. So here's what I know. I know that tangent of theta is 2 over x. And that's all I needed. Any equation that connected theta to x. There it is.
And we already know what x is.
Not yet.
Oh, all right.
Got to differentiate first. Got to differentiate first. So you have some options here. You could just take the derivative right now, both sides, with respect to time. You want to do that?
Yes.
Yes? Okay, I'll stick with that. What's the derivative of the left side with respect to time? What's the derivative of tangent theta? Secant squared theta, drum roll,
Times theta. Times d.
times d
D theta.
theta over dt. Chain rule. Taking derivative of tangent of something is secant squared of the something. Now go inside, take derivative of that theta, the something in there, is d theta dt. If you forget that, you're never going to see it, right? You're never going to have that piece you're trying to solve for. What about the right side? Don't do quotient rule. Don't do the quotient rule. I know you're tempted to do the quotient rule.
What are we doing?
Rewrite that as 2 times x to what power before you take the derivative? No, no. 2x to the negative 1.
So it'll be negative 2x.
Rewrite the 2 over x as 2x to negative 1, then take your derivative. What would it be?
Constant just comes along. So
Negative 2x to the negative 2 dx dt. Good. There we go.
hey, our negatives cancel.
Y'all see that derivative? All right, I don't like the way that looks. Because the negative exponents, I'm just afraid that something's going to go wrong with that. So I'm going to go secant squared theta d theta dt equals negative 2 over x squared dx dt. I just dropped the x to negative 2 down because I didn't want any issues with it. All right. Let's skip the secant theta for just a second. D theta dt is what I'm trying to solve for, so I'm happy to see it. Do I know x at the moment in time?
Yes.
Yes, it is root 32. Sorry, that's dx dt, not dx dx. dx dt is negative 600, right? So I'm in business, but I need to figure this out. Secant theta squared. So can you tell me from this picture, because I can look at this picture now in the instant time, what is secant theta by definition?
Hypotenuse over adjacent.
It's hypotenuse over adjacent. What is the hypotenuse over the adjacent? 6. So this is going to become 6 over root 32 squared. Do y'all see that? Secant theta is hypotenuse over adjacent, that's secant theta. Square it. Times d theta dt equals negative 2 over, what's x squared? Root 32 squared is going to be 32. And then dx dt was negative 600. Secant squared theta is 1? How do you get that? No, it's over 32, not over 36. How'd you get 1? Is that how you got 1?
Yeah.
Okay. It's kind of weird that I saw that that's what you did, huh? All right, we have squaring that fraction over there, 36 over 32 times d theta dt equals, my goodness, 1200 over 32. Do you agree with that? And I noticed something that I can just multiply both sides by 32 right now because they both have a denominator 32. Yeah?
Well, couldn't you just do it by the reciprocals?
Yes, I could. I'm just if I were doing it, I just would have done that, and they would have been gone, like that. And then divide 1200 divided by 36. And what do you get? Please, somebody.
33.333.
d theta dt is what? 33.33?
Just repeating.
100 over 3.
100 over, oh, okay, gotcha. All right. It just doesn't look right to me, but it's okay. I'll double check it. What is that? Yeah, so this is where we go back and we look at the units. Let's do the time one. What is this measured in?
Hours.
Hours, right? So this is per hour, but it's what per hour? It's an angle, right? Theta. And the angles that we have in trig are usually in degrees or radians, right? We have not talked about degrees at all. Your answer will always be in radians, unless you convert it to degrees. So at this point, this is radians per hour. Radians per hour. You can just say rad per hour. Rad over hour. Anybody remember how to convert from radians to degrees?
Yeah.
How?
Dimensional analysis.
33 radians over 1. You multiply that times
I don't remember
what?
how many
180 degrees
degrees over
is pi radians. And so please, if someone would do me the favor, 33.3 times 180 divide by pi. Not all at one time, please. No one is going to do me the favor? All right.
100.
I guess I'll have to do it. Times 180 divide by pi. 1,907.9 degrees per hour. What we're saying here is at the moment that the plane is exactly 6 miles from us, the angle of the radar station is turning at a rate of 1,907 degrees, which is like a huge number, but what? Per hour, right? You could convert that to like per second to get a better idea of like how fast it is, but that's the answer. That's how fast it's rotating. We're going to spend more time doing this, obviously, on Thursday. Start your homework for this. Work through as many of them as you can. I've done all the homework problems on video. And what I've noticed is that the homework assignment that you're given on the syllabus or on the schedule isn't really that robust. It has a lot of the easier problems on it, but doesn't have some of the challenging ones. And so in the video at the very end, I say, hey, you should look at this problem, this problem, this problem, this problem, some other additional ones. I plan on doing those videos also. I just don't know when. I'm kind of busy this week. I don't know if I'm going to get to them.
The videos on the ones you suggested?
I did all the homework ones. The ones that I suggested you also look at, I have not done the videos for. I will plan on doing those hopefully, I don't know, before the weekend is what I'm hoping for. Okay, let me turn off my camera and then I'll answer questions.